Hello guys. So this week I'm going to be going over the first PowerPoint for physics. In this physics unit, we're going to talk a lot about light, how light travels, what does light do when it hits a reflective surface, what does light do when it travels through a transparent surface. And we're going to start that conversation with a conversation about what exactly light is, which is a form of energy that travels in a wave. And we're going to talk a little bit about other forms of light that you may not be super familiar with because you can't see them, and that is known as the electromagnetic spectrum. So, my first question that I'm going to is thinking about today, which you'll probably already have some ideas about, is have you ever wondered about how your remote control is able to control your television without being connected? So there's no cord that's leading from your remote control to your television. You can move it around the room, point it in different direction, but as long as there's nothing in front of your television when you're trying to send the remote control, that way you are able to change the channel without getting up. So this is all related to waves, and we'll talk a little bit about why that works. Another question I have for you to kind of think about is how you're able to chat with your friend on the cell phone, and you can be anywhere to do this. So your friend could be all the way in India, but you could have a conversation with them in Canada. Again, this is related to waves. So the goal for this lesson today is I'd like you to understand a little bit about how waves can transfer energy and how they do transfer energy, as well as identify various uses of the electromagnetic spectrum, which is just another word for light, and where those different areas of the spectrum can emit from. So, waves are a way of transferring energy through space. As you're sitting in your house at this very moment, there are waves that you cannot see that are being transmitted through space. They could be waves that are coming from the sun. If you've got a window in your room, they're going to be microwaves that are coming from your cell phone. There's going to be waves coming from you because you produce energy in the form of heat. So this is all going on practically invisibly in your apartment or house. So waves are a way of transferring energy through space. The sun sends out infrared waves, which we'll talk about a little bit later, towards the sun, which is how the planet is kept warm. So there's natural ways that waves are used to transmit energy, but there's also ways that scientists have found that they can manipulate and use waves for communication or for other uses like your cell phone and remote controls. So most waves are completely invisible to the naked eye. There's a very, very, very small section of the electromagnetic spectrum, which we're going to talk about today, that you can actually see. So this is giving you kind of a visual of what's kind of going on that you're not actually aware of. So, electromagnetic radiation. So electromagnetic radiation is a way of classifying light. So there's only a certain part of light that you can see. The rest of light is invisible. That's the electromagnetic spectrum. So when you think of light, you probably think of what your eyes can see. So you're sitting at home, it's dark, you want to read your book, you turn on the light, then you can see. That's light. You go outside, you look up at the sun, it's coming through the clouds, that's light. But light is not just what our eyes can see, that's just what our eyes are sensitive to. So it's just the beginning, it's just a sliver, a small portion of the total amount of light that surrounds us. So there's a large amount of light that we actually cannot see. So the electromagnetic spectrum is the term used by scientists to describe the entire range of light that exists. So there's some examples on the side. So radio waves are a form of light. Microwaves are a form of light. Infrared rays are a form of light. That's what's being used to control your TV remote. Visible light, that's the small section that we can see. Ultraviolet comes from the sun. X-ray, gamma ray, all of these are types of waves that we classify as light. So we traditionally think of visible light as our kind of definition of light, but it's only really the light that we can see. So as I mentioned, there are 7 different types, or I would rather call them regions, because they're part of a spectrum. So they all fit along the same line. They don't come from different sources. They're just stronger or weaker variations of light. So we're talking about radio waves, microwaves, infrared, visible light, ultraviolet, X-ray, gamma ray, etc. So all of these things fit along a spectrum. Visible light, this is the light that we traditionally think of as what we can see. This is including light bulbs. This is including the sun. This is including all that you can kind of see in the world. Other forms of light is we're talking about radio waves. So they're sitting a little bit lower on this spectrum. All the way to gamma rays, which are created through radioactive explosions, and they're sitting on this side of the spectrum. And they are completely different in size, so there's quite a bit of distance. So in between each of these waves, that's sitting around the size of a building, versus as we get all the way to gamma rays, we're talking about the distance between them being smaller than an atom, which, for a little bit of perspective, because we haven't talked about atoms yet, because we haven't gotten to chemistry, that's smaller, quite a bit smaller than a human cell. So just because you're probably already noticing that the difference between these waves is that they're getting a little bit closer, I'm going to give you a little bit of terminology to help you kind of understand that. So waves, things that are used to transfer energy, can have different amplitudes. So that means that they can have different heights. So a low energy wave has a low amplitude, it's less high, versus a high energy wave is going to have a higher amplitude. We don't need to worry about that too much, but I want you to keep that in mind when you're looking at some of the images you might see. So low energy, low amplitude, high energy, high amplitude. And this is the most important part. So waves can also have different wavelengths. So in between a wave, the distance between the waves can kind of vary. So this is the difference between us being able to see this range in here, visible light, versus not being able to see these ones that have smaller spaces in between them, gamma rays. So the distance between the light wave is actually controlling what it's being used for. So you can think of it as the same kind of string that encompasses all of these different things, but kind of dependent on the speed and the amount of space in between that, that's controlling kind of what it can be used for or how dangerous it is. So shorter wavelengths have a high energy and a high frequency. So items on this edge of the spectrum are going to be higher energy, more dangerous, and have a higher frequency because their wavelengths are closer together. So it's just shorter wavelength. Versus this one over here has a lower frequency. There's more space between the waves. So it's a long wavelength. This is a low energy wave, and it's got a low frequency. So in between this space, if I look at this space here, if I kind of divide that out, the amount of humps in between, that's what the frequency is. So I've got 1, 2, 3, 4, 5, 6 versus 1.5, or maybe 2 in there. So this one's got 5 where this one's got 2. So it's a lower frequency. There's less wave kind of humps between this distance where I'm counting. So long wavelengths equal low energy, low frequency. So they're not going to be as dangerous, and they require less energy to produce. I like to think of this, and you can try this at home if you'd like to, if you have a little piece of rope. If you had a partner and you had a little piece of rope, to whip the rope back and forth to make sure that there were lots and lots and lots and lots of humps and less space between these waves, you'd have to use a lot of energy. Versus if you did it slower, you could use less energy. So that translates into the same kind of explanation here. So the ones that are close together are higher energy. The ones that are further apart are lower energy. So all of the things on the electromagnetic spectrum have a different wavelength. And they range from longest wavelength to shortest wavelength. So this is called the electromagnetic spectrum. So all of these things we're classifying as light, but only this tiny, tiny, tiny sliver is considered visible light. So it's moving from low energy all the way to high energy. So that's the main thing I want you to understand, is that when we're moving from radio waves, those are lower energy waves, versus when we move all the way to high energy gamma rays, they're going to be needing a lot more energy and are a little bit more dangerous. Okay, so where does this electromagnetic radiation come from? So we know that it's coming from light, and light is a form of energy. But where are some sources that we can find it? So we can find electromagnetic radiation in devices that are created by scientists and inventors. So cell phones use a type of electromagnetic radiation to communicate, light bulbs, microwave ovens, lots of different things. But it's also found in natural and living sources. You, for example, give off a form of electromagnetic radiation called infrared or heat. So you give off body heat. So there's artificial man-made sources, but there's also natural and living sources that give off electromagnetic radiation. Stars, the sun, plants, dogs, animals would all fit under this. They all give out certain forms of electromagnetic radiation, but there's also artificial things that we've created that do. The sun, funny enough, gives off all of those 7 types of electromagnetic radiation, as do many things in space. Electromagnetic radiation, as I mentioned, lots of it is not very visible to us, but it enhances how we sense or see our world. So you, in fact, are an electromagnetic radiation detector. Right now you might be feeling too hot. That's your own electromagnetic radiation detector kind of going off and telling you that information. So skin has special cells that sense infrared radiation, and they send that message to your brain, and they interpret it as heat. So that prevents you from getting overheated or getting too cold and getting frostbite, is that your body is sensing that type of radiation. Your eyes sense visible light to see brightness and objects of color, so you're able to see visible light. Different types of animals can see different types of the electromagnetic spectrum. So for example, some insects can actually see UV light, which we're going to talk about a little bit later. Electromagnetic radiation and technology often let us see in a new way. So this picture here is a picture of a supernova, which is an exploding star. The reason why we can see all these things in space is because we have telescopes that can sense or kind of see different types of electromagnetic radiation. So we have certain telescopes that can give us infrared views of the universe or X-ray views of the universe, which can let us see different kind of things in space. So for example, this image over here, I believe uses visible light. This one over here is using infrared light. So we get a very different view of the same galaxy. This one is using visible. Oh, so this one's got to be using something else. I can't see what it is. And this one is using X-ray light. So with this technology or kind of understanding of the electromagnetic spectrum, we can get very different kind of views of the universe and the world around us. So we're going to talk about some of the things that you can kind of see in the world around you, but these are kind of an idea of just how kind of prevalent all of these waves are in your life. So we've got lots of examples of ultraviolet radiation, so tanning, sunglasses prevent you from getting UV damage, radios used for communication, for television, satellites, etc. So the first type of wave that we're going to talk about is radio waves. The radio wave wavelength is the longest wavelength, and it has the lowest energy, which means that it's got the least amount of humps. Uses for radio waves are often for communication systems. So fire, police, emergency systems will use radio waves because they're a very reliable means of communication. Radio stations generate radio waves. So if you're driving around in a car, you might tune to a certain radio station. That's kind of tuning to a specific kind of wave that's going to come into your car and be kind of transferred into that information. So that's how that kind of music would be delivered. They send signals to radio receivers. So that signal is sent. Your car is obviously not plugged in when it's driving, so the signal is sent. And then the radio receiver that gets them in your car is going to convert that into sound. They're also used in MRIs, which is like a type of body scan. Microwaves. So your cell phone that you might be holding right now is a source of microwaves. That's how it uses, that's how it sends information to cell towers, so that cell tower can send that information to whoever you're trying to communicate to. So cell phones are a source of microwaves. Microwaves carry information from a cell tower to a nearby cell phone tower. So they take that information. So it transmits from your cell phone and is carried in the wave. And then on the other end, that information is kind of recoded so the person can understand it. Microwaves also use microwaves to heat your food. They're a little bit more of a complex process, but that's how that is happening. So there's waves that are being used to activate atoms in your food. Infrared, you might have seen infrared images before. So infrared is given off by living things. So this dog is giving off infrared light. So you can actually tell where he is hot through these infrared goggles. So there's certain types of goggles that actually allow you to see infrared. Snakes are a creature that can see infrared as part of their kind of visible spectrum. So they can actually see infrared, but this is kind of an idea of what infrared heat is. Your remote control uses infrared, and fires will give off heat. So they give off infrared radiation. So all objects, including you, give off infrared radiation. It's just something we don't see because we're not wearing infrared goggles. As objects get hotter, they give off more infrared radiation that is sensed as heat. Uses, as I mentioned, remote controls. Computers use infrared to read CDs and DVDs. Heaters use infrared to heat your place, and infrared goggles are able to sense or see infrared. Sometimes this is used in the military to do kind of raids and sneak up on kind of and make sure that there's no people kind of lurking around that could be hurt or hurt other people. Dangers of infrared, obviously overheating. So if you sat too close to a fire and too many layers of clothing, you could start feeling kind of sick because your body is getting too hot. So infrared radiation is all about heat. And again, it's sitting on the electromagnetic spectrum. So we've already covered radio waves. So as we can see, our waves are getting higher and higher in energy because they're getting closer and closer together. So examples of radio waves, televisions, radios. You'll notice on this diagram that it's divided into AM radio and FM radio. FM radio is a little bit different than AM radio because the frequency is higher than AM, so that's something to kind of notice.